Hello, my name is Mohammad Javaheri, and in this video I will go over the solution to the following geometry problem. In the triangle ABC, we are given the angle ABC and angle ACB both equal to 80 degrees. The line segment BD is drawn in a way that the angle measures of ABD and DBC are 20 and 60 degrees, respectively. The line segment CE is drawn in a way that the angle measures of ACE and ECB are 30 and 50 degrees, respectively. The question is, what's the angle measure of BDE? First, we will draw a line through D that is parallel to BC. Call the intersection of that line with the segment BA F. Then we connect point F to point C. Call the intersection with the segment BD H. Connect H to E. Draw a perpendicular through B onto the segment FC. Call the intersection with FC G. And so this angle is 90 degrees. Call the intersection of the perpendicular line we just drew with the segment EC point I. And connect I to H. Well, we first noticed that angle DFH is congruent to angle FCB. So this angle is congruent to this angle because the lines we drew here, the line DF is parallel to BC. And so by the alternate interior angles theorem, we know that this angle would equal this angle. And moreover, we know that this angle, same reason, same logic, this angle is congruent to this angle. Well, this angle is 60 degrees. And so FDH is 60 degrees. And by symmetry, therefore, this angle is also 60 degrees. So this is also angle DFH equals also 60 degrees because of the symmetry in the figure. You see that this line is parallel. It's an isosceles triangle. And so when you're connecting D to B and F to C, because of the symmetry, we can argue that this angle is congruent to this angle, 60 degrees, this is also 60 degrees, and therefore this is also 60 degrees, making the triangle FHD an equilateral triangle. So the triangle FDH is equilateral. All right, so keep that in mind. Next, let's focus on the line BG relative to HC. We also notice that the triangle HBC is an equilateral triangle. 60 degrees because of the symmetry. This is also 60 degrees. And so this is an equilateral triangle. And so this line BG that we have drawn, which is perpendicular to the segment HC, is indeed a perpendicular bisector of HC. And I, being on that perpendicular bisector, should be equidistant from H and C. And so this angle here would be congruent to this angle. So angle GHI equals angle GCI. Now, what's the angle measure of GCI? That would be 10 degrees because together with this 50 degrees angle, it should make a 60 degrees angle. So this angle here, the angle GCI, is 10 degrees. And so this angle is also 10 degrees. 10 degrees here. And that lets us be able to measure this angle now. This would be 20 degrees because it's an exterior angle. And so it's a sum of these two interior angles. And so angle HIE equals angle GCI plus angle GHI equals 20 degrees. So this angle here is 20 degrees. This angle here is 10 degrees. Now let's focus on the quadrilateral EHIB. I claim that this is inscribed. We know the major theorem about inscribed equilateral figures is that if we have an equilateral, it is inscribed if and only if the opposite angles add up to 180. And another equivalent formulation is that in this picture, ABCD, this angle would be congruent to this angle. Angles opposite to the same segment from the other two vertices would be congruent. And this is an if and only if statement. So if these angles are congruent, then the equilateral is inscribed. And in this picture, you see this was 20 degrees. This angle EBH is 20 degrees. The angle HIE is also 20 degrees, which makes this the quadrilateral EHIB an inscribed figure. Well, then we could use that fact to show that this angle is congruent to this angle. Again, this is because this is an inscribed quadrilateral, and so the angle HEI is congruent to angle HBI, which we know is 30 degrees, because recall that this is a perpendicular bisector of the segment HC, and this angle is 60 degrees, so this is 30 degrees, making this one also 30 degrees. All right, we're getting closer to our goal here. The next step in the process of the solution is to figure out what this angle is. Now we note that actually this line F goes, this line FG goes through H. So the sum of FHE and EHI and IHG must be 180 degrees. This one we know is 10 degrees. This we can calculate because in this triangle EHI, we have two of the angles. We have a 20 degrees and a 30 degrees angle, which makes this one 130 degrees. They have to add up to 180 inside the triangle. All the angles add up to 180, 30 and 20, remaining would be 130. So this is 130. And so what we were looking for should be 40 degrees so that it adds up to 180. So this green angle here is 40 degrees. Angle FHE is 40 degrees. On the other hand, this angle is also 40 degrees. This we could have said right from the beginning because we knew that this angle is 50. Sorry, this angle is 60 degrees. This angle is 80 degrees. The sum of angles in a triangle should be 180. So we can measure this angle, and this will also be 40 degrees. So the angle EFH equals 40 degrees. And as a result, we can say that the line ED is perpendicular to FH. In fact, it has to be the perpendicular bisector of FH. Recall that FHD was an equilateral triangle. So DF equals DH. On the other hand, we just showed this triangle is isosceles. So FE equals EH. So both points E and D are equidistant from F and H. So as a result, we can say that DE is the perpendicular bisector of FH. And in particular, this should be 30 degrees because this angle was 60 degrees. And so this is the bisector, the angle bisector, and so this should be 30 degrees. So the angle EDH equals 30 degrees. All right, that's it for me. If you have a different solution of this, please share it in the comments. Thank you very much.